This is the second 5.3 video. We're going to look at the general multiplication rule to calculate probabilities. So the general multiplication rule is the multiplication rule that works whether the events are independent or whether they are not independent. In previous videos, we've learned the general addition rule, where the general addition rule works for events that are disjoint or they are not disjoint. Later in the video, we're going to look at another multiplication rule that only works for events that are independent. This general multiplication rule will work for all sets of events, whether they're independent or not independent. And so all this is saying is the probability of A and B is equal to the probability of A times the probability of B given that A has occurred. Let's take a look at an example how to use this. So the Pew Internet and American Life Project reported that 79% of teenagers use social media and that 39% of teens who use social media feel pressure to post content that will be popular and get lots of comments or likes. Find the probability that a randomly selected teen uses social media and feels pressure to post content that will be popular and get lots of comments or likes. So this second probability here, 39%, is conditional. It's 39% of teens who use social media. So it has to be known that they use social media, given that they use social media. So let's write this out here. So we're looking for the probability that they use social media and they feel pressure, and we can apply the general multiplication rule. So the probability that they use social media times the probability that they feel pressure given that they use social media. This is conditional because if they don't use social media, then they can't feel pressure, right? So it has to be known that they use social media. And so the probability that they use social media was 0.79, and the probability that they feel pressure given that they use social media was this 0.39. So we're just going to multiply those two together. And so 0.79 times 0.39 is 0.308. So there is a 30.8% chance that they use social media and feel pressure. So the reason I taught you this general multiplication rule first is because it's extremely helpful when we're using a chance process that has a sequence of outcomes. And we're going to express a sequence of outcomes with what's called a tree diagram. And it shows the sample space of the chance process involving multiple stages. And the probability of each outcome is shown on the corresponding branch of the tree. So all probabilities after the first stage are conditional probabilities. So let's look at just a quick example or visual of a tree diagram. We've got Shannon who has two events. She either hits the snooze button or she doesn't, and she either gets to her first class on time or she does not. So it's a sequence because first she's going to hit snooze or she's not going to hit snooze. Then she's either going to be on time or late, whether she hits snooze or if she doesn't hit snooze and she's on time or she's late. So we'll come across a problem where they'll give us these probabilities and we're asked to make this, but I wanted to give you a visual first. So if Shannon hits snooze, what's the probability that she arrives to her first class on time? So this is a conditional statement. If she hits snooze, it's given that she hits snooze. So given that she hits snooze, what's the probability that she's on time? So all of these here are conditional statements because the first event has already occurred for each of them. So the probability that she's on time given that she snoozes is right here, 0.70. The probability that she is late given that she hit snooze is 0.3. The probability that she is on time given that she doesn't snooze is 0.9. The branches are always going to add up to 1 because she's either going to be on time or late if she snoozes. And she's either going to 0.6 plus 0.4, she's either going to snooze or she's not going to snooze. There's a 100% chance one of those two will happen. And if this happens, there's a 100% chance that one of these will happen. She'll either be late or she'll be on time. So what's the probability that Shannon hits the snooze and arrives to her first class on time? This is a multiplication statement. And all we have to do is we multiply the probability of them both occurring. So we're using the general multiplication rule, probability that she snoozes is 0.6. Probability that she's on time, given that she snoozes, on time given that she snoozes is 0.7. So we're going to multiply this 0.6 times 0.7 to get our answer. So there's about a 42% chance that she snoozes and is on time. So whenever you have an and statement like this, you're just going to multiply the branches together. So the probability that she doesn't snooze and is late is 0.4 times 0.1. Let's look at a little bit more complex example. Recently, Harris Interactive reported that 20% of millennials, 25% of Gen Xers, 21% of baby boomers, and 17% of matures, age 68 or older, read more ebooks than print books. According to the US Census Bureau, 34% of those 18 and over are millennials, 22% are Gen Xers, 30% are baby boomers, and 14% are matures. Suppose we select one US adult at random and record which generation the person is from and whether she or he reads more ebooks or print books. So these first probabilities they've given to us are conditional. We know that they're millennials. 20% of them read more ebooks. We know that they're Gen Xers. 25% read more ebooks. So first, they want us to use this sequence of events. First, we're going to randomly select a person, and then we're going to figure out whether they read more ebooks or more print books. So they want us to draw a tree diagram to illustrate this chance process. So this is the outcome of the first event. If I randomly choose a US adult, they'll either be millennial, Gen Xer, baby boomer, or mature. And the probabilities are listed here. They've told us that 34% are millennials. So I'm going to add 0.34, and 22% are Gen Xers. 30% are baby boomers, and 14% are mature. So I should add all these together and make sure that they all add up to 1, because if I randomly select a person, they will have to be in one of these 4 categories. Now, after I've selected the person, the next question is, do they read more ebooks or do they read more print books? So I've listed all possible outcomes from the next events. And if they're millennial, these are the conditional statements now. So knowing they're millennial, what's the probability they read more ebooks? And that's what this first probabilities were listed in the problem. 20% of millennials read more ebooks. 25% of Gen Xers read more ebooks. So I'm going to put this 0.2 or 20% that they read more ebooks, given that they're millennial. That means there's an 80% chance that they read more print books, given that they're millennial. Each of these tree branches should add up to 1. So I'll continue with Gen X, baby boomer, and matures. Okay, so now I have all my conditional statements listed here, or probabilities listed here. The key for a tree diagram is figure out the order of events, and then you need to be able to figure out from the problem which ones are the conditional statements, because those are always going to be the probabilities that are listed second. Now, the next thing I like to do is I like to list out, this here is technically the sample space, because if I randomly select a student, I'm either going to get a millennial that reads more ebooks, a millennial that reads more print books, a Gen Xer that reads more ebooks, or a Gen Xer that reads more print books. One of these final outcomes is going to happen. It's guaranteed to happen. So this here, I'm going to list out the probabilities of each of these events to occur, and that's going to be the probabilities of my sample space. So the probability that I randomly select a millennial that reads more ebooks is just going to be 0.34 times 0.2. And I'm going to write that probability right here. So you can see I've written out my sample space and the probability of each event. One of these events is going to occur. If I randomly select a student or an adult, because they're either going to be one of these and they're either going to read more ebooks or more print books. So my sample space, all of these probabilities, if you add them up together, it's going to equal 1. And this first one here is the probability of them being a millennial and them reading more ebooks. So the second one would be the probability of them being millennial and the probability that they read more print books. This one here would be the probability that they are a baby boomer and they read more print books. So you don't need to write the same, you don't really need to write each of these out. I just wanted to give you a visual to see what this probability is calculated. So some teachers don't require you to write the sample space. I want you to write the sample space out every time because it's going to be really helpful for actually answering questions about these sequence of chance processes. So find the probability that the randomly selected person is a baby boomer and reads more print books. So we've already done that because we've listed out the sample space. The probability that they're a baby boomer and read more print books. Baby boomer, 0.3 times read more print books, 0.79. So here's our answer, 0.237. So there you can see 0.237. You do not need to write all this out. I just want you to see that this is still using the general multiplication rule. Probably them being a boomer and read more print books is them being a boomer times probability of them reading print books given that they're a boomer. So given that a person is a Gen Xer, what's the probability that they read more ebooks? Write it in probability notation first. So what's the probability that they read more ebooks given that they're a Gen Xer? If it's a conditional statement, then we know it's going to be one of these probabilities here. So given that they're Gen Xer, the probability that they read more ebooks is this 0.25 right here. Find the probability that a person reads more ebooks than print books. So this one is where we get a little more complex because there are lots of options that satisfy this event. We're just looking to see if they read more ebooks. So they could be a millennial and read more ebooks, or they could be a Gen X and read more ebooks, or baby boomer, more ebooks, or mature and more ebooks. So if you haven't realized, and statements are multiplication, or statements are addition. So we have to add up the probability of all of these different events to get the probability that we randomly select somebody who reads more ebooks. So these are all the possible ways that we could select somebody who reads more ebooks. So I need to add them together. These or statements imply that I need to add each of these together. So the probability that they're millennial and they read more ebooks, we already have these probabilities written out. So here it is here. Probably that they are Gen X and they read more ebooks. Gen X and read more ebooks is right here. Same for baby boomers and then for mature. So I'm just going to add those probabilities together. Okay, so the probability that I randomly select somebody and they read more ebooks is 20.98, or almost a 21% chance of that happening. So the last question, suppose the chosen person reads more ebooks than print books. What's the probability that she or he is a millennial? So this is a conditional statement. We've been given that they read more ebooks than print books. So this is what we're trying to find, the probability that they're millennial, given that they read more ebooks. So now we're going to have to jump back to this conditional probability statement or formula. And the formula is the probability that they are millennial and they read more ebooks divided by the probability that they read more ebooks. So this probability right here is the probability of randomly selecting somebody that reads more ebooks. Well, we just found that in this last problem. So that's going to be this 0.2098. Now we just need, what's the probability that we find we randomly pick somebody that's a millennial and they read more ebooks, which we've done already. So our answer, this 0.068 came from our tree diagram. Probability that they're millennial and read more ebooks right here. And like I said, this came from the previous problem. So the probability that we pick somebody that's a millennial, given that they read more ebooks, is about 32.41%.